Welcome you all. This is the first class of second law of thermodynamics. In this session, we will discuss briefly about the introduction of second law of thermodynamics. That means, what is the importance of this second law of thermodynamics? Why it is introduced? So this is very basic question. What is the role of second law of thermodynamics and where it is used? For understanding this concept, first of all, we need to understand what is the drawback of first law of thermodynamics. So we need to understand first of all the drawbacks of first law of thermodynamics. So as for first law of thermodynamics, basically it states that energy is conserved. That means it does not give any information regarding the direction of particular process. That means in which direction this process is carried out, it does not give any information regarding that one. So this is the main drawback of first law of thermodynamics, that the first law only says that energy is conserved, but it does not give any direction of this particular process. Therefore, just to find out the direction of particular process, the second law of thermodynamics is introduced. The second law basically gives the direction of process with the concept of entropy. Okay, so with the concept of entropy, the second law of thermodynamics basically gives us the direction of process, like from 1 to 2 or 2 to 1, because if any process will be carried out, then definitely this process will be either 1 to 2 or and left to right and right to left, or top to bottom or bottom to top, and these are the direction of this process. So this direction of any process can be found out with the help of second law of thermodynamics. Therefore, the second law of thermodynamics also called directional law of thermodynamics. Okay, so basically the second law of thermodynamics gives the direction of process. That means whether this process is feasible or not. If feasible, then in which direction this process will be carried out. So first of all, the feasibility of any process is important to know. If any process is there, whether this is feasible or not. If feasible, then in which direction this process will be carried out. So this is basic concept of this second law of thermodynamics. So in practical, first of all, we need to apply the second law of thermodynamics so that it could be confirmed that whether this particular process is possible or not. If possible, then in which direction this process will be carried out with the concept of entropy. So this is the main advantage of second law of thermodynamics. So in one line, if for understanding this one, why second law of thermodynamics is introduced, its answer is the second law of thermodynamics basically gives us the direction of process with the concept of entropy. Okay, this one term, new term is introduced, is entropy. We'll study in depth about entropy in this section. Okay, this is first important thing we need to understand, right? Okay, the next important point is that just it is written in this topic. Okay, in this first paragraph, whatever we have explained, these things are written in this first paragraph. So go through this one, you will come to know what. Just simply you have to listen and watch this video very carefully so that you can understand why the second law of thermodynamics is introduced. Okay, next point is that basically we have familiar with work and heat, because in previous section we studied about work and heat, right? So basically what is basic difference between work and heat? This is a very important question. What is basic difference between work and heat? Because whenever heat is supplied, this work is done. Whenever work is done on the system, this heat is rejected. This is the we have studied in first law of thermodynamics. So in this section, basically work and heat can be classified on the basis of grade of energy. Okay, on the basis of grade of energy, this heat is called low grade energy. Okay, this heat is called low grade energy and work is called high grade energy, right? Because work is important, whenever heat is supplied, then how much work is obtained from that process, this is very important. So main thing is work. Okay, so that's why this work is called high grade of energy and heat is called low grade energy. Suppose that if you want to start any project and some quantity of suppose that if you want to start the project and some amount of fund is required to run this project. So this fund basically concerned with this heat. Okay, whenever this fund is required, whenever you invest some fund to run this project, there is some work output, there must be some work output. So this is very important. So that's why if you invest some amount in any project, then you are supposed to get some work output. So that's why the work is called high grade energy and heat is called low grade energy. Okay, so this is the second statement. This is the it is written here, work is known as high grade energy and heat is known as low grade energy, right? Now it is very important to understand that it is impossible to convert, impossible to complete conversion of heat into work. Okay, this is a very important statement, you need to understand it very carefully. The complete conversion of heat into work is not possible. That means whenever heat is supplied to any process, it is impossible to complete conversion of heat into work. There must be some losses will be there. Understand? Because these losses means this complete conversion of heat into work is not possible. This is the main gist of second law of thermodynamics. Okay, so whenever heat is supplied to any process, any system, then there must be some losses, and due to these losses, this complete conversion of heat into work is not possible. Okay, so it is impossible to convert low grade energy into high grade energy. We can say this statement that because we are saying that complete conversion of heat into work is not possible, and we are saying that heat is a low grade source of energy and work is high grade source of energy. That means it can be said that complete conversion of low grade energy to high grade energy is not possible, right? Okay, next term, just we are talking about thermal energy reservoir. Okay, so basically thermal, as its name suggests, that thermal energy reservoir. So first of all, we need to understand what is reservoir. So reservoir is just like it is the space of infinite amount of whatever quantity you want to store. This is called reservoir. So this is suppose that this ocean. What is ocean? Ocean is the in ocean, the huge amount of water is stored in ocean. Huge quantity of water are stored in ocean. That means if some quantity of water is taken out from this ocean, this level of water does not change. If some quantity of water, some gallons, some tons, and if any quantity of water, if you place in ocean, the level of water does not change. So ocean just like a reservoir of water. What is ocean? Ocean is the reservoir of water. Similarly, this one term here introduced, thermal energy reservoir. That means this is the reservoir in which some quantity of heat, if added or removed, it does not suffer the temperature change of this reservoir. So what is thermal energy reservoir? Thermal energy reservoir is the storage of huge quantity of heat in which if some quantity of heat is added or rejected, it does not suffer any temperature change. So this is called thermal energy reservoir. the thermal energy reservoir is classified into basically two categories, source and sink, right? The source, what is source? Source is the supplier of heat energy. Source is the supplier of heat energy, and sink is the absorber of heat energy. That means a source always supply the heat energy at higher temperature. Understand this one. Source always supply the heat energy at higher temperature, and sink always absorbs the heat energy at lower temperature. So this is basic difference between source and sink. The source is the supplier of heat energy at higher temperature, and sink is the absorber of heat energy at lower temperature, right? Okay. Now, basically we have discussed previously that complete conversion of heat into work is not possible. This is a very important statement, because basically now we'll move to some statement which comes under the second law of thermodynamics. There is one statement, this is called Kelvin-Planck statement, right? This is the Kelvin-Planck statement. Okay, so this is what basically it says. We have already said that complete conversion of heat into work is not possible. That means if some quantity up, and we are saying that source is the supplier of heat, so suppose that this Q1 amount of heat is, suppose that in this figure, just we have to understand what is the meaning of this one, what is the basic things of we have to understand in KP statement. Suppose that this is source, okay, the source supplies this Q1 amount of heat to the heat engine, and it delivers W work. So this KP statement says that it is impossible to construct a heat engine which produces equivalent work while transferring of heat from single reservoir. That means if, suppose that if in this, let us assume that in this diagram, okay, in this diagram, just we are removing this sink from this figure so that it could be understood. Okay, just look at this figure. It is impossible to construct a heat engine which produces equivalent work while transferring of heat between single reservoir. So, okay, so understand, this is the main statement of KP statement. Okay, Kelvin-Planck statement basically says that it is impossible to construct a heat engine which produces equivalent work while transferring of heat from the single reservoir. That means, what if it is impossible to construct a heat engine which completely converts heat into work? It basically states same statement, because that means it is such types of heat engine is not possible. It cannot be made which completely convert this heat into work. In other words, the KP statement says that it is impossible to construct a heat engine which produces equivalent work while transferring of heat from the single reservoir. Here only source is there. There is no sink. That means only one source is there. This source supplies Q1 amount of heat to the heat engine, and this heat engine converts completely into work. So such types of heat engine is not possible. So it is written, it is impossible to develop a device which operating on cycle, right, which produces work while exchanging heat with a single reservoir. That means this is source. Such types of heat engine is not possible. Such types of heat engines called PMM2, perpetual motion machine of second kind. Such types of heat engine called perpetual motion machine of second kind, right? So perpetual motion of second kind of heat engine cannot be made. It is impossible. Okay, because such types of engine will have 100% efficiency, because work output is W and heat supplied is Q1. Since whatever heat is supplied, it completely converts into work. That means this Q1 will be equal to W. So the efficiency will be 100%. So efficiency of this heat engine will be 100%. Such types of engine is not possible. There could not be, this is impossible to construct any types of engine which gives 100% efficiency, right? So this is the main statement of Kelvin-Planck statement. Therefore, then what is the possibility? Then how will it possible? So this KP statement, such types of heat engine not possible. That means we have to add a sink. This is the concept of heat engine. This is concept of heat engine. That means what is this heat engine? This heat engine, it absorbs Q1 amount of heat from source. It delivers work output W, and some quantity of heat is rejected to sink. This is called heat engine. Suppose that you are just you can place here just yourself at this heat engine. Suppose that if you are placing here in place of heat engine, that means you take some quantity of heat from food, you develop some quantity of work, and you reject just some wastage, right? So just man itself a engine which extracts some quantity of energy from foods, he delivers some work output, and he rejects some wastage. Okay, so this we can place yourself in place of heat engine. So this is concept of heat engine concept develops from the KPA statement, because such types of heat engine is not possible, because PMM, perpetual motion machine of second kind, is not possible. This PMM2 machine is what? This is that types of engine which completely converts heat into work. Okay, so in order to feasible this one, we have to add one sink. Okay, the sink will have temperature TL, the source having temperature TH and sink having temperature TL. This is the concept of heat engine. So in this condition, this Q1 amount of heat is added to heat engine. This heat engine delivers work output W and rejects Q2 amount of heat. So this Q1 is equal to W plus Q2. From this equation, this Q1 is equal to W plus Q2. So this Q1 is equal to W plus Q2. So what is the work output? This Q1 minus Q2. This work output is equal to Q1 minus Q2, right? And this efficiency, what is efficiency? Efficiency is equal to work output by heat supplied. So this is work output by heat supply, and we know that this work output is equal to Q1 minus Q2. Simply we have to put this value in this equation, this Q1 minus Q2 by Q1. This will give 1 minus Q2 by Q1. So efficiency of this heat engine, all heat engine, whether reversible or irreversible, it does not matter whether it is reversible or irreversible, efficiency of all heat engine is equal to 1 minus Q rejected by Q supplied, right? This is the efficiency of heat engine. Okay, so this is the basic statement of KP statement, and the concept of heat engine comes from the Kelvin Planck statement, right? Now the second statement is Clausius statement. Clausius statement, basically what does it deal? The Clausius statement simply deals that it is impossible to construct a device which will operate in cycle, okay, which will operate in cycle, produces no effect other than transfer of heat from lower temperature to higher temperature. Understand? It is impossible to construct a device which will operate in cycle, produces no effect other than transfer of heat from lower temperature to higher temperature. That means it is impossible to construct a device which transfer heat from lower temperature to higher temperature without adding any types of work input. Without doing any work input, it is impossible to construct a device which will transfer the heat from lower temperature to higher temperature, because we know that this heat always flows from higher temperature to lower temperature. But this such type of device cannot be made which transfer the heat from lower temperature to higher temperature without adding any work input. That means if you want to make such type of device, that means you will have to do some work input. You have to do some work on this device so that it could transfer heat from lower temperature to higher temperature. So this is the statement of Clausius. This is called Clausius statement. Means such types of device cannot be made which automatically transfer heat from lower temperature to higher temperature. For this purpose, we have to do some work. We have to do some work on the system. We have to add some work input to the system so that this heat could be transferred from lower temperature to higher temperature. This is called Clausius statement, right? So this is Clausius statement. This is refrigerator. So concept of refrigerator comes from this one. So in this refrigerator, that means this is the basically this is refrigerator. what is this Clausius statement says that it is impossible to construct a device. Suppose that this refrigerator is device. It is impossible to construct a refrigerator which automatically converts the transfer heat from lower temperature to higher temperature. Okay, what is the lower temperature? That means if any refrigerator, if you are talking about any refrigerator, that means lower temperature means temperature inside the refrigerator, and higher temperature means temperature outside the refrigerator. So without adding any work inputs, it is impossible to construct any refrigerator which automatically transfer the heat from lower temperature, that means storage, to outside. That means how is it possible? We have to do some electrical work. If you plug in your refrigerator, that means you supply some work input, you supply some power input to the refrigerator. If this power input is supplied, this power input is supplied, this refrigerator starts to run. Okay, and during this running process, this amount of heat, whatever heat is extracted from this storage space, that means suppose that if you place some food, yeah, if any types of stuffs are taking place inside the refrigerator, this some quantity of heat is withdrawn from this food stuff, and this quantity of heat is rejected outside to the refrigerator. So this is called refrigerator. Okay, so let us this is in this figure, this refrigerator R, this refrigerator, this work input, this one the work input W, and this, by adding this work input, this Q2 amount of heat is extracted from a storage space, right? What is your storage space? This place inside your refrigerator, because you have to maintain this temperature of refrigerator at lower temperature, right? So when this work input or power input is supplied to refrigerator, this Q2 amount of heat is start to suck from storage space, and this Q1 amount of heat is rejected to surrounding. And we know that the surrounding always at a higher temperature. This storage space always at lower temperature, because we have to maintain the storage space at lower temperature. So whenever this work input or power input is done, this power input means this electrical power input, whenever this work input or power input is applied to the refrigerator, this Q2 amount of heat is withdrawn from the storage space, and this Q1 amount of heat is rejected to surrounding. This is at higher temperature. This is the concept of refrigerator. That means in this diagram, in this refrigerator, what is our system? Our system is this storage space. This storage space is our system, because we have to maintain the temperature of this storage space at lower temperature. So this is our system, right? So remember this one, for refrigerator, our system is this storage, this is this lower temperature, this is sink, right? Okay, then one very beautiful equation of this, whenever we will discuss about refrigerator, this coefficient of performance comes. Okay, this coefficient of performance is equal to desired effect by energy input or work input. So what is our desire? Our desire is to maintain this storage space at lower temperature. In refrigerator, what is our desire? Our desire is to maintain the lower temperature inside the storage space. So this is our desire, to maintain lower temperature inside the storage space. How this desire will be fulfilled? If by extracting Q2 amount of heat from the storage space. So this Q2 amount of heat is extracted to fulfill our desire. So this is desired effect is Q2 amount of heat is extracted from the storage space, so that temperature could be maintained at lower temperature. So this desired effect is fulfilled by Q2 amount of heat is extraction of Q2 amount of heat. This Q2 by work input, energy input is work input. So COP of refrigerator is equal to Q2 by W, and this COP of refrigerator, we know that by energy balance equation, W plus Q2 is equal to Q1. Okay, this is written here. W, this is work input, Q2 is this input, this W plus Q2 is equal to Q1. Therefore this work input is equal to Q1 minus Q2. Q1 minus Q2, simply we have to put the value, this Q1 minus Q2, therefore COP of refrigerator is equal to Q2 by Q1 minus Q2, right? So this is the COP of all refrigerator, whether reversible or irreversible, right? Next thing is heat pump. What is the heat pump? Heat pump is the device which basic purpose of heat pump is to maintain the temperature of room at higher temperature. Okay, so this heat pump is the device which makes the storage space hotter, right? So this is the heat pump. So this heat pump, this of course our system will be this one, because this Q1 amount of heat is added. How this temperature, how this this temperature could be maintained. Suppose that if your room at in colder climate, you have to maintain the temperature of room at higher temperature. Then how is it possible? You just use some heater, okay, or blower. Just this what does this heater or blower do? This blower heater supplies some quantity of heat inside your room, and by adding this heat, this temperature of room becomes hotter, right? So this is that means our system is source, because source always at higher temperature. So this is our system, right? So in this condition, this heat pump is a device which maintains higher temperature compared to surroundings. Okay, compared to surrounding, that means in colder climate the surrounding temperature is lower and you have to maintain the room at higher temperature. So this is a device which maintains higher temperature of your room compared to surrounding. Higher temperature of the system. What is our system? Our system is our room, our storage space. This is room, our storage space. So this heat pump is a device which maintains higher temperature compared to surrounding. In this condition, this higher temperatures will be our system, and therefore in this condition, what is COP? COP is equal to, once again, COP is a ratio of desired effect by work input. And how this our desire is fulfilled? This by adding this Q1 amount of heat, our desire is fulfilled. Therefore, the COP of heat pump is equal to Q1 by W. And you know this W is equal to Q1 minus Q2 from this equation. W plus Q1 is equal to W plus Q2 is equal to Q1. Therefore, this W is equal to Q1 minus Q2. So simply you have to put this value. The COP of heat pump is equal to Q1 by Q1 minus Q2. This equation is valid for all types of refrigerator. Remember, this heat pump, this equation is valid for all types of heat pump, whether reversible or irreversible. Okay, so there should not be any confusion. Whenever this COP is in terms of heat, that means this is valid for all types of either refrigerator or heat pump. Okay, so this is all about the discussion regarding. First of all, we understood there are some important things. First thing is, what is the drawback of first law of thermodynamics? Next, what is the role of second law of thermodynamics? Then Kelvin Planck statement, then Clausius statement, then concept of heat engine, concept of refrigerator, and concept of heat pump. These things we have discussed in the session. We will discuss further topics in next class. Okay, thank you very much.